Correction factors. That is what this tutorial is all about, correction factors. This property behind me has been rented out for several years. They're moving back and they want all new radiators throughout, which is fine. However, they want to make it heat pump ready. So when it comes to calculating radiator sizes of heating systems, they should now be heat pump ready, which means the flow temperature should be set to 55 degrees, no longer 75 degrees. So let's have a look around inside the property, let's measure up some radiators, and I'll do a working example on how to do the new heat loss calculation for the radiators at 55 degrees. Enjoy! So, this is a double fin radiator. The other thing to discuss is 8mm microbore pipe. So microbore's pipe can be used for heat pump. It's not ideal, it can be used, but you have to look at what kilowattage can be delivered through microbore, and I'll discuss that as well. A lot of heat pump installers don't actually install thermostatic radiator valves, and the reason behind that is a thermostatic radiator valve can adjust the flow rates, but not only that, when you design heat loss room by room and a thermostatic valve switches off, then you're affecting the heat loss or gain going to the following room. That we'll discuss later on. Now it's also worth noting that when you do actual full room by room heat loss, that the air changes now are pre-2000. And it's also worth noting the ground floor is classed as the outside temperature. For this example, we're upgrading a radiator 450 high, 1100 wide, 8mm K1. So, it's a K1 radiator, 450 high by 1100, which is there. We'll come across. The wattage for that radiator is 845. So, let's look at the heating system using a heat pump. The flow temperature is going to be 55 degrees. The return temperature on the heating system will be 45 degrees. So the mean temperature is 50. So we've got 50, the mean working temperature. Deduct the desired temperature, 29. Using the Stelrad correction factor chart, 29 will give us 0.491. So here we have the Stelrad correction factor chart, because the radiators are designed for heating system giving a flow of 75. Here we have the delta T 29, so the correction factor is 0.491. So, next stage, the correction factor. This can give us the current operating factor, how much heat the current radiator will give out. So 845 watts times 0.491 will only give 415 watts, which makes sense, doesn't it? It's half. The correction factor, 845 watts, divided by 0.491 will give us 1731 watts. So theoretically speaking, we've got to practically double the radiator. So here we have a problem using 8mm pipe for the heating system. The maximum wattage you can get from 8mm pipe is 1500 watts. 10mm, 2500 watts. So I might have to upgrade the pipe work to 15mm. Now for something completely different. Did you know a radiator bleed key can wind a grandfather clock up? Who'd have thought?